Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarah Shazza, Matric 8. My matric number is 211021185. I will explain to you about the butterfly multiclass image classification CNN. Here's step by step to explore butterfly multiclass image classification CNN. Step 1, import libraries. Step 2, data analysis and visualization. Step 3, splitting dataset. Step 4, building the model. And step 5, evaluating model performance. The import libraries, I use TensorFlow and Keras through which the proposed model of CNN will be designed and trained. The next libraries that I use, which is a pandas, to manipulate the data and load the CSV that contain the respective path to the image along with data label. The next library that I use, which is NumPy for numerical operation and handling. And the last one, Matplotlib and Seaborn for data visualization and plotting graph. For step 2, which is a data analysis and visualization. The first step, which is loading and exploring the dataset. The dataset is loaded using the pandas and the first few entries are displayed to understand the structure. Next is count the number of image per class. This count the number of image for each butterfly class and sort the count of by the class, which is they have a 6,499. For the next step, which is a plot distribution of butterfly classes. This create a bar plot showing the distribution of butterfly classes in the dataset. As you can see, I use a class count to count the number of an image per class and sort by the class. Here the result of plot distribution of butterfly classes. As you can see here, they have a distribution of butterfly classes, and number of images. Next, we'll go to plot percentage of each butterfly classes. This create a pie chart showing the percentage of representation of each butterfly classes. As you can see here, I use the colors to define the colors for the pie chart based on the class count. For plot the percentage of each butterfly class in the pie chart, as you can see, it will divide by the percentage of each butterfly classes. Next, we go to display sample image. This sample have a 9 random image from the data frame and display them in a 3x3 grid. I use image dir for define the directory where the image are stored, and I use sample image to get a 9 random image from the data frame. Here are the result of the 9 random sample image. For step 3, which is a splitting dataset, they have a data pre-processing in here, which is we use image augmentation and data generator. Image augmentation to enhance the model generation capability. For data generator to separate the generator for training and validation sets. For step 4, which is building the model. To build the model, we need to compile the model by use ADA optimizer and category cross entropy loss function suitable for multi-class classification tasks. Next, we go to the train the model. The model is trained off for the specific number for approach with both training and validation data generator. For example, I use a 40 approach. Step 5, which is evaluating model performance. To plot training, validation, accuracy, and loss. After training, the model's performance is evaluated by the plotting, training, and validation accuracy and a loss curve. As you can see the result, this visualization helped in understanding the model learning process and identifying the potential overfitting and underfitting issue. Let's take around the result, which is they have a 2 plot, which is one is model accuracy and another one is model loss. We move to the last step, which is a predict and display image with a prediction. The trained model can be used to make a prediction on new image by processing them similarly to the training data and using the model predict function. Here I use a val image, val label to get a batch of validation image and label. Another one, I make a prediction. I use the pred label, and a true label to get a true labels of a butterfly. As you can see in the code, I use the def display image to function to display image with the true and the predict label. I call image true label, prediction label, class name, and number of image. At the end of the result, it will display the true of the named classes of butterfly and the prediction of classes butterfly. Here the result, 9 of images of the true and the prediction butterfly classes. For the conclusion, the model was able to reach an accuracy 70% of validation set. The accuracy curve covers several lines, while the confusion metric highlights base classification between the species with a similar pattern. Data augmentation helped the reduce overfitting as seen in the smooth validation loss curve. That's all from me. Thank you.